everybody. We are going to do a word problem about a landscaping company. And what we're going to do is we're going to do this word problem using substitution and elimination, one of each method. And of course, we know that we'll end up with the same answer because that's what substitution elimination does. So, a landscaping company placed 2 orders with a nursery. The first order was for 13 bushes and 4 trees, totaled that much money. The second order was for 6 bushes and 2 trees, totaled that much money. The bills do not list the per item price. What were the costs of one of each? So, let's label things. We care about bushes, we care about trees. Let's let bushes be X. Let's let trees be Y. So order number 1, okay? And this is gonna be the same exact system for both problems, but I'm just gonna write it. I'm gonna do substitution first. Order number 1, 13 bushes, 13X, 4 trees, so plus 4Y, 13 bushes and 4 trees totaled $487. Okay, 13 bushes, 13X, 4 trees, 4Y totaled $487. Okay, second order was for 6 bushes, so 6X, and 2 trees, 2Y, and that's going to total $232. Okay, so to do substitution, what I have to do is I have to get one variable all by itself. And that's not at all the case in either of these. Now, looking at this, I have an X up here, I have a Y up here, 13 is attached to X, 4 is attached to Y. I know if I had to get any of those by itself, I'd have to eventually divide those numbers. And looking at that number right there, I really don't want to divide anything. So what I'm going to do is I'm looking at this X, but more specifically that Y down there. That Y only has a 2 attached to it. So if I were to get Y all by itself for the bottom equation, it's not the end of the world. So I'm going to take the bottom equation. I'm going to rewrite it out right here. And I'm going to get Y all by itself. So starting us out is subtracting 6X minus 6X. 2Y equals, these two don't combine, negative 6X plus 232. Y is still not all by itself. I have to divide both sides by 2, divide both sides by 2, which means divide everything by 2. Y will equal negative 6 divided by positive 2 is negative 3. X comes along for the ride. 232 divided by 2 is 116. All right, so that was my bottom equation. Now solve for Y. My bottom equation. What I have to do is, now that I know what Y is, I have to throw that into the top equation. So I'm going to rewrite the top equation, and instead of Y, I'm going to replace Y with negative 3X plus 116. So this is the top equation, 13X plus 4Y, and instead of Y, I now know Y is negative 3X plus 116, and then continuing equals 487. Okay? 4 is attached to a parentheses, which means distributive property here. 13X 4 times negative 3X is negative 12X. 4 times 116. 464, I knew that. 464 equals 487. This is convenient. 13X is right next to negative 12X, which means I have 13 X's, or in this case, 13 bushes. Take away 12 of those bushes leaves me with just one of them. X plus 464 equals 487. In order to get X all by itself, I have to subtract 464 minus 464. Cross that out. X equals 23. Now that's my x. I still need to find my y. I could plug that into either of the original equations, or since I have an equation right here that says y, I could just take that x equals 23 and plug it in there. So that's what I'm going to do. Y equals, I'm rewriting this equation right here, y equals negative 3. Instead of x, I'm going to substitute x with 23 plus 116. Negative 3 times 23, I don't know why I did that, negative 69 plus 116. Negative 69 plus 116 is 47. All right. Now, what I needed to do was find the costs of one bush and one tree. So what this means is since x was 23, y was 47, bushes was x, bushes cost $23. Trees, which was y, cost $47. All right. So that's substitution. Elimination. Same exact system of equations, okay? 13x plus 4y equals 487. 6x plus 2y equals 232. Now, the nice thing about elimination in this case is everything is already lined up. The x's match up, the y's match up, the equal signs, and the regular numbers. However, at this very moment, the x's won't disappear and the y's don't disappear. Now, the closest thing that will disappear is the y's. If I have a 4y up here, all I have to do is multiply this guy down here by negative 2, and that will turn that into negative 4y, and then the y's will go away. So this bottom equation, if I multiply negative 2 to everything, becomes negative 12x minus 4y equals 464. So let me rewrite everything without that sloppiness, okay? The top equation stays the same. Okay, that's me writing out the top equation. My new bottom equation is negative 12x, negative 4y, and negative 464. If I add these equations, it's going to look very familiar to what I did in substitution. 13 plus negative 12x is going to be regular x. These guys disappear, and as I might remember from that guy right there, 487 plus negative 484 is 23. Looks familiar. Now if I have x, I need to plug it into one of the original equations to find y, so let's plug it into the bottom. I'm going to rewrite that bottom equation, 6x plus 2y equals 232. I now know that x is 23, so I'm going to rewrite this and replace x with 23 plus 2y equals 232. Multiply these guys together. That is 100, 6 times 23, 100, I don't want to risk it. 138 plus 2y equals 232. Subtract 138 from both sides. 2y equals 94. Divide both sides by 2. Y equals 47. So up here, x was 23. Down here, y is 47. And what we know that means is bushes cost $23, trees cost $47. So, there you have it. In all of its glory, doing a word problem using both methods and finding out that we get the same exact answer no matter how we do it. Okay? Thanks for watching. Bye!